Okay, so welcome back for part 2 of section 17.3. We're finding extrema. We're finding maximums and minimums for multivariable functions. So here's our next example. We're looking at this f of xy here is equal to 7x cubed plus 3y squared minus 126xy minus 63. So let's just dive right in. Step 1, or part 1, or however you want to think of this. Find those first partials. So what is f sub x? Well, f sub x is going to give me 21x squared minus 126y. And then f sub y, the first partial with respect to y. First term nothing, second term 6y minus 126x. All right, now that I've found them, I need to take both of those and set them both equal to 0, make a system and solve that system. So I've got 21x squared minus 126y equals 0. And I have 6y minus 126x is equal to 0. Okay, this is a non-linear system because of that squared right there. So I can't use elimination or any of those techniques like that. So it looks like I'll probably have to use substitution. So I am going to solve this second equation for y because it looks easy, and then substitute that into the first equation right there. Okay, so the second equation for y gives me 6y equals 126x. Divide both sides by 6, so y equals 21x. And now this goes there. Okay, so now I've got 21x squared. Actually, you know what? I'm going to change colors so we can see that a substitution occurred. Let's go to red. I've got 21x squared minus 126 times 21x is equal to 0. And I'm going to factor that. You'll notice that I didn't multiply this out because I saw something that's going to make it factoring easier. So I've got 21x times x minus 126 is equal to 0. So this piece gives me that x could be 0 or x could be 126. So it looks like we've got two candidate points here. Okay. If x is equal to 0, what's y? Well, the way that I find that y is I'm going to go back and do a substitution. So if x is 0, y is 21 times 0, so y is also 0. And if x is 126, what's y? Let's see. Y is equal to some ungodly big number. It's going to be 21 times 126, whatever that is. I need a calculator for that. Hold on. All right, so that works out to be 2146. Woo, that's a big one. Okay, so I've got 2 points. Now that I know that I have 2 candidate points, I'm going to go ahead and test those. But in order to test those, I need that discriminant. And so if you remember, the discriminant was f sub x, x times f sub y, y minus f sub x, y squared. So in order to do that, we need to first find all those second partials. So let's go ahead and start. What is f sub xx? Looks like that's going to be 42x. And f sub yy will be 6. And f sub xy is going to be negative 126, whichever way you find it. Okay, so now I can use these to build that discriminant and test each of those 2 points. Okay, so I'm going to call this point 1, and that's going to be the point 0, 0. So the value of the discriminant at the point 0, 0 is going to be 42 times 0, there's f sub xx times f sub yy minus f sub xy squared. And I really don't care what that number is, but I know that based on this, it's going to be less than 0. So that means that the discriminant is less than 0 there. So I'm going to go back up to my rules. And what does it mean when the discriminant is less than 0? Well, let's get rid of all this because that was for the last problem. If the discriminant is less than 0, we're looking at a saddle point. So now that we know we have a saddle point at 0, 0. Okay, now let's take a look at point number 2. That was the point 126, 2,146. Okay, all right, so let's see. So the discriminant there at that point 126, 2,146 is going to be f sub xx, so that's 42 times x, which is 126, times f sub yy, which is 6, minus f sub xy, which is negative 126 squared. I might actually have to calculate that out to see whether that's bigger than 0 or less than 0. So let's go ahead and grab this. So 42 times 126 times 6. 31, so minus 126 squared. It's positive. That makes sense, yeah. So it's positive. So this is greater than 0. So now I'll go back up here and I'll say, what does it mean when it's greater than 0? Okay, when the discriminant is greater than 0, so now we're looking at here or possibly here. So we're looking at either a max or a min based on whether the second partial x is greater than 0 or less than 0. So at that point, the second partial x was greater than 0. So we're looking at a minimum. The second partial x was just this piece right here. So that was greater than 0. So we're saying then we have a minimum, a relative minimum, at the point 126, 2,146. And then if I need that minimum value, I need to take this point and put it back into the original function. This guy. That's a calculator problem if I ever saw one. So let's see. 7 times 126 raised to the third, 7x cubed. Oops, I don't want that there. I want that there. Plus 3 times 2,146 squared minus 126 times 126 times 2,146 minus 63. And so I get a minimum value of, what was that again? 625,137.9. 625,137.9. Negative 6,251,379 is our minimum value. That was lovely. Right. So I did the math and I found out that this thing has a saddle at 0, 0 and a minimum value of negative 6 million change. Right. Don't focus on that number. It seems absurd, and it kind of is. Focus on the process. The process is finding minimums, finding maximums. How do we do it? We find the first partials, make a system, set it equal to 0, solve it. That gives us candidate points. In this case, it gave us 2 candidate points. Right? Once we have our candidate points, we then find the value of the discriminant. So find those second partials, plug in your candidate point, see what you get. Compare it to the rules. Is it greater than 0? Is it less than 0? If your discriminant is less than 0, you've got a saddle point. If your discriminant is greater than 0, then you have to look at the second partial xx and determine whether that's positive or negative. If it's positive, then you're looking at a minimum. If it's negative, you're looking at a maximum. If they want the value, put the candidate point back into the original function. Find that minimum value. Right? The process is very straightforward. The math can get kind of ugly, especially this part right here. This is the part that can be the worst, is finding those candidate points by doing all those steps. Okay, so just be careful there. All right, let's try another one. Our function is g of xy is equal to e raised to the function x times y plus 1. All right, step 1. Find those candidate points. So what is g sub x? Let's see, if I remember from earlier, d dx of e to the u is e to the u times u prime. But when we find this u prime, we're going to have to use partial derivative rules. Right? So it's going to be e to the x times y plus 1 times derivative of that exponent with respect to x. So that derivative of that exponent with respect to x is just going to be the y plus 1. So there's my g sub x. Now I'll find g sub y. That's going to be e to the x times y plus 1 times, and then the derivative of that exponent is going to be x. And so there's my first partials. Now I need to make a system and set that system equal to 0. So I have e to the x times y plus 1 times y plus 1 is equal to 0. And I have e to the x times y plus 1 times x is equal to 0. Okay. All right, how do I solve that? Well, any way I can, but there's a rule in math that says that those two things, that exponential term, since it has not been translated vertically, it will never be equal to 0. Okay? I'm making use of the zero product principle. The zero product principle says that if you have two things, whether it's the first equation or second equation, if you have two things that are multiplied together and the answer is 0, one of those must be 0. Since this one can't be 0, that one has to be 0. So my second equation tells me that x is 0. Same logic. The first equation tells me that y is negative 1. So I only have one candidate point to test. That's not too bad. All right, so how do I test it? I need to do the discriminant. But in order to do the discriminant, I need my second partials. So what is g sub xx? Well, g sub xx is going to be the derivative of that first g sub x with respect to x. So let me see here. I've got two things being multiplied together. There are no x's over here, so that's just a coefficient. So that's just going to drag along. Times, and then I take the derivative of this with respect to x again. And so that's going to be e to the x times y plus 1 times another y plus 1, or if I clean that up a little bit, that's going to give me y plus 1 squared times e to the x times y plus 1. Okay? And now I'll find g sub yy. Well, logic, same logic. There's no y there, so that's just going to be a coefficient, so it'll just drag along. And then I take the derivative of this piece right here with respect to y. And so that's going to be e to the x times y plus 1 times another x, or x squared times e to the x times y plus 1. Okay, how about then second partial g sub xy? I'm going to take the derivative of the second one with respect to x because I think that would be easier just because there's less. Okay, that's going to be a product rule. So the derivative of the first one with respect to x is going to be e to the x times y plus 1 times y plus 1 times the second plus the derivative of the second with respect to x times the first. Ooh. Let's see if I can clean this up a little bit. Is this e to the x times y plus 1 times x, oops, xy plus x plus 1. Okay. All of this, distribute, gather it up, factor out the e to the x, gives me this right here. Okay. Now I need to take my candidate point, my partial derivatives, and make it into the discriminant. All right, so the discriminant for the point 0, negative 1 is going to be xx at the point 0, negative 1. But, and remember, I'm lazy here. I'm looking ahead. When I put that there, is that going to make that 0? And then the 0 times e to the x is just going to be 0. So xx is going to be 0. All right, times yy. Well, when I put that there, is that going to make that thing 0? Minus xy squared. Okay. Okay, well, I think I actually have to plug this one in because I don't see it going to be simplifying. So it's going to be e to the 0, because it'll make that exponent 0, times 0 plus 0 plus 1 squared. 0, e to the 0 is 1, times 1 is 1, squared is 1, so minus 1, so that's less than 0. It's negative 1, it's less than 0. So then I'll go back up and check and see what that means. Let's see. Oh, saddle. So we have a, oops, saddle at 0, negative 1. Oh, that was fun. I like that one. Okay, now I know what you're thinking. You're thinking, woo, that was a lot. And there were a lot of places where I could have made mistakes. So I really want to check my work on this one. So let's go look at the picture. There's the picture. And do you see the saddle at the origin there? How it's a low point in one direction and a high point in the other direction. So there's our saddle. That's gorgeous. That's a much better view. That is a lovely saddle. And a beautiful graph too. Kind of cool looking. Yep, there's our saddle. Love it. All right, so that brings us to the end of video 2 for 17.3. I'll see you all back here for part 3.